My dear students, in continuation of our mark scoring videos for senior intermediate, today we are going to discuss the same chapter, that is current electricity. There are two essay type questions regarding potentiometer. So let us straight away go to those two questions. State the working principle of a potentiometer. Explain with the help of a circuit diagram how the EMF of two primary cells are compared by using a potentiometer. That is the first question. Second question is almost all same. State the working principle of potentiometer. Explain with the help of circuit diagram. Up to here everything is same. But how the potentiometer is used to determine the internal resistance of the given primary cell. So this is the second question. If you see these two questions, only variation is seen here. So here the comparison of two EMFs of two cells, that is E1 by E2. Here to determine the internal resistance, small r. So before I go into the potentiometer, let me tell you about EMF. EMF is defined as electromotive force. It is full name is electromotive force. It is defined as the potential difference between the positive and negative terminals of a battery or a cell. So EMF is nothing but the voltage difference between plus and minus terminals of a battery when it is not connected to anything else. So battery is in open circuit and I am measuring the potential difference between these two. So if I measure the potential difference between the two terminals of a battery, then that is called as EMF, electromotive force. Now what do you mean by internal resistance? A cell consists some chemicals. Cell also consists some metal rods, cathode and anode. So this chemical, or it is also called as an electrolyte, chemical metal installations inside the battery, they also have some resistance. So that resistance is called as internal resistance. Internal means inside. So every cell or a battery has got some inbuilt internal resistance. Inside resistance of a cell is called as internal resistance. It is indicated by small r. So you know this is the symbol for electric cell, and internal resistance is taken as in series to the battery or a cell. So this is the indication of internal resistance. If you know this, that is enough. Now what do you mean by a potentiometer? So potentiometer is not a device. It is not a ready-made device that you can buy in the market. So it's purely an electric circuit. Potentiometer is an electric circuit by using which you can do the following things. So you can determine EMF of a cell. You can determine the EMF of a cell. You can also determine EMF of a cell by using a simple voltmeter. Voltmeter is a device which measures the voltage, that is the potential difference. Then why should I use potentiometer only? Potentiometer is the device, or potentiometer is an instrument which measures the EMF by not drawing any current from the cell. Let me tell you once again. Suppose this is an electric cell. If I want to measure the potential difference between these two terminals, then I connect it to a voltmeter. So what does a voltmeter do? It draws current from this cell. So the cell is losing some current while its EMF is being measured with the help of a voltmeter. Whereas if I use a potentiometer is not going to draw any current from the cell whose EMF is being measured. That is the difference. So no current is drawn, here current is drawn. That is the reason why using potentiometer is an ideal situation to measure the EMF of a cell. Right. So the first application of potentiometer is to determine the EMF of a given cell. Number 2, you can compare the EMFs of two cells. Comparison means taking the ratio. This is our first question. Explain with the help of circuit diagram how the EMF of two primary cells are compared. Is this clear? Right. That is done. Now, what do you mean by a primary cell? Cells are of two types. One is primary and the second one is called secondary cell. Primary cell is, in general, is a non-rechargeable cell. Primary cell is a non-rechargeable cell, whereas secondary cell is a rechargeable cell. Your mobile phone cell is a rechargeable cell. Ordinary torchlight cell is a primary cell. That is the difference. Right. The third advantage or the third application of using potentiometer is you can determine internal resistance of the cell. So this is the third question. So third question is related to finding the internal resistance. Second question is related to comparing the EMFs of two cells. Is this clear? Now, let us try to learn about potentiometer now. Now let us go into the construction part of a potentiometer. Now, a potentiometer consists of a wire of length of 10 meters or 7 meters. So 7 to 10 meter length of wire is used in a potentiometer. That is the basic structure of a potentiometer. Now I take a wire of length 10 meter. So how can I put that 10 meter, wire of length 10 meter in the laboratory? So I cannot use that much length, working table to do this experiment or to construct a potentiometer. So what we do in general, we take a wooden plank, generally of length 1 meter, on which I arrange this wire of length 10 meter by arranging it in 10 rows. If it is 7 meter length, I will arrange it in 7 rows. Let us say this is of length 10 meter. So I have one pin here, another pin is here like this. This is a conducting one. Is this clear? So I am arranging this 7 to 10 meter length of wire 10 parallel lines on a wooden plank. This wooden plank is also fitted with a 1 meter scale. So this is a scale having 100 centimeters. Why I am using scale, that we will be knowing later. Now what type of wire it is? It is a wire made of constantan or manganese. Why only these two wires are used? They are alloys. So alloy is nothing but the mixture of two or more number of metals. Why I am using only constantan or manganese? Because these two wires or these two alloys have a property. What property they have? Their resistance will not change with the temperature. So if I increase the temperature or decrease the temperature of the wire, resistance is not going to be altered. Generally, in general, the resistance of any metal or any metallic wire changes with that of temperature. So RT is the resistance of the wire at temperature T, R0 is the resistance of the wire at temperature 0 degree Celsius. Here alpha is called temperature coefficient of resistance. So since alpha is positive, definitely for all metallic conductors, RT is greater than R0. Is this clear? Right. So you have to use a wire of length 7 to 10 meter, and that wire is arranged like parallel lines on a wooden plank, which is also fitted with 1 meter square. Right. So, this is the basic ingredient of potentiometer, right. So, instead of drawing this diagram in some textbooks and in some other guides, they draw the diagram, but that is of no use. Now, let us draw the diagram like this. Let us say this is wire AB of length 10 meter. Now, these two ends are connected to a standard battery. Standard battery means whose EMF is known, a reference battery. So, it takes the current from this battery instead of taking the current from the other battery whose EMF is to be measured. And two ends of wire are connected to the standard battery via a rheostat. What is a rheostat? Rheostat is a variable resistor whose resistance can be changed. So, I am changing the resistance. If I change the resistance, the value of current also changes. So, current I is flowing through this. I can fix the value of I by changing the resistance, that is nothing but by moving this pin on the rheostat. If I move rheostat to other end, resistance increases. If I move the rheostat pin to this side, resistance decreases. When resistance is less, current is more. When resistance is more, current is less. I fix some current. So, this circuit is called primary circuit. This circuit is called primary. When I say primary, there must be some secondary circuit also. Now, secondary circuit is this one. So, to the same point A, I connect it to another battery whose EMF is to be determined. So, this is given battery. I connect it to a galvanometer and to a jockey. Jockey is nothing but what do you call a metal pin like this pen. So, I can move it from A to B. So, when I move the jockey J from point A to B, at some point, at some length of the wire AB, galvanometer deflection becomes 0, null deflection. In that case, potentiometer is said to be balanced. As we see the same, we already came to know about the balancing in Wheatstone bridge. So, Wheatstone bridge is also said to be balanced if the galvanometer reading is 0, right. Now, why the galvanometer reading is 0? What is the reason? Now, try to learn the principle, the working principle of potentiometer. Now, let us try to learn the working principle. Let us say the EMF of this one is, the standard cell is 10 volt. That means this is plus, this is minus. So, here you have 10 volt, here you have 0 volt. As you go from A to B, the voltage decreases. As you go from A to B, the voltage drop. The voltage on the wire decreases. So, suppose here if it is 10, then it will be 8, here it will be 8, somewhere 6, somewhere 4, somewhere 2, somewhere 1, now 0. As you go from A to B, the voltage at a given point on the wire decreases. That means there is a potential drop across the length of the wire AB while you go from A to B. Is this clear? Right. Now, potential drop, that is nothing but voltage, is equal to IR. I is the current flowing through the primary circuit. R is the resistance of the wire. Suppose AJ is the point I am considering, J is the point on the wire. If I want to calculate the potential drop at this point, I have to measure this length L. How this length is measured? By making use of our meter scale. So, just now I told you for this wooden plank at the lower end meter scale is there. So, I am moving from A to B. So, this end is B and this end is A. Is this clear? So I am moving the jockey on this. At one point, deflection becomes 0. So if there are 4 lengths, that is 4 meter. So I moved from here to here, let us say 20 centimeters. So I have moved 420 centimeters. That is the balancing length. No need to draw the diagram for our exam purpose. You try to learn the working principle. So potential drop or voltage at point J is given by IR. So you know this is from Ohm's law, but resistance is directly proportional to length. I is constant, R is proportional to length. So I can write potential drop on this wire is directly proportional to length. So if the length is more, potential drop is more. If I reach 10 meter from this, that means I am reaching point B. The whole potential is dropped, that means the whole 10 volt here becomes 0. If I am at this point, the length is very less, so potential drop will be less. So here, let us say 9 volt. How much potential is dropped? Potential is dropped by only 1 volt. Here, the total potential is dropped, so that is the reason why 0, the potential drop is 10 volt here. So potential drop depends on the resistance of the wire, resistance depends on the length of the wire. So I can write directly potential difference or voltage across the wire is proportional to the length of the wire. Is this clear? Right. So while I am moving jockey from A to B, at one point Ig becomes 0, that means the potential drop or the potential present here is equal to the EMF of this one. This potential is equal to this potential, so current never passes between 2 points which are of same potential. There is no potential difference here and here. So when I connect this, current will not flow. So this is my galvanometer. Current never passes between 2 points which are at the same potential. Is it clear? Right. That is the reason why galvanometer showing 0. Is this clear? Right. So how to measure E1? Depending upon the length. Now let us go to the first question. So what you have to write under the subheading principle? Potential drop across the wire is directly proportional to the length of the wire. If you write that, that is enough. So you have to write voltage is directly proportional to L. So write this line, write this statement, write this statement, write this in a box. So construction will be given some 2 marks, for principle you will be given some 1 or 2 marks. The remaining, so for the both the questions, this part is same. Construction is same and principle is same. Is this clear? Right. Let us go to the first question. This is very, very important. If you don't get a Wheatstone bridge question, definitely you will be getting potentiometer question. Out of these 2 potentiometer questions, you may get the first potentiometer question or the second question on the potentiometer. Right. Understanding is very, very important. This is very, very important question. Right. Now, state the working principle of a potentiometer, that we already did. Explain with the help of circuit diagram, that also we already did. How the EMFs of 2 primary cells, are compared by using the potentiometer. So how many cells are given? For me 2 cells are given. I have to compare their EMFs. How these 2 cells are connected? These 2 cells must be connected in the secondary circuit, not in the primary circuit. So once again, I will draw the diagram. Right. So this is wire AB. First draw the primary circuit consisting of the standard EMF, standard cell of EMF E0. This is connected to rheostat. The RH is the symbol used. So this is the diagram. This is the primary circuit. Primary circuit is same in all the diagrams, in all the circuit diagrams. Next, this point is connected to 2 given cells, cell 1, cell 2 of EMFs E1 and E2. Is this clear? Right. These two cells are connected to a two-way key and connected to galvanometer and to a jockey J. Let us name these 3 points as P, Q, T. When I connect P and T, only E1 will be in the secondary circuit. If I connect only Q and T, this E1 will be in open circuit and the current flows through only E2. Is this clear? Right. Now, the first one is you connect like this. Now connect points P and T. So how current flows? So current flows like this through E1 and through galvanometer and through jockey. Now these two are connected. P and T are connected. Though you have E2, it is not connected. So it is in open circuit. Only current flows through E1. Right. Now what you have to do? You have to move the jockey from A to B. You have to move the jockey from A to B till it shows null deflection, that is current in the galvanometer becomes 0. You know galvanometer has a needle, the midpoint is 0. If current goes on one side, it's a positive direction. If it goes in the other direction, if the deflection is on the left side, the current direction is reversed. So here it is balanced. Balanced means the potential here is equal to the potential of the battery. Is this clear? Right. Let us say the balancing length is L1. So from the working principle it is clear. While I move the jockey from A to B, I got balance at a balancing length L1. So from our principle I can write E1 is directly proportional to L1. Is this clear? If you want, you can put a constant, proportionality constant KL1. Then what is K? K is called potential gradient. No need to know what is potential gradient right now. Simply say K is a constant. This is equation number 1. Is this clear? Very simple. Now, remove the connections between P and T. Now P and T are disconnected, but S and T are connected. So connect points S and T of two-way key. Now current is flowing through E2. So now E2 is in the circuit, is in the secondary circuit. Is this clear? Right. Now repeat the same experiment. Move the jockey from A to B till you get a deflection 0, null deflection. In that case, let us say the balancing length is L2. So directly you can write E2 is directly proportional to L2. So this is the second equation. If you want, you can write E2 is equal to some constant K times L2. This is equation number 2. Now what I do, I take the ratio 1 over 2. Equation 1 over equation 2. So E1 by E2 is equal to K times L1 divided by K times L2. K gets cancelled. So L1 and L2 are known numbers. You will get a ratio of 2 numbers. You will find some number as your answer. So this is the way of comparing the EMFs of 2 given primary cells. That's all. If you write up to this, you will get 8 marks. Is this clear? In the exam, you are supposed to draw only this diagram, the primary circuit and the secondary circuit. Your secondary circuit consists 2 primary cells of EMFs E1 and E2 they are connected to a galvanometer and jockey via a two-way key. Is this clear? If you write this much, you will get 8 marks. Very simple. Straight away write E1 proportional to L2, L1, E2 proportional to L2. Take the ratio, E1 by E2 is equal to L1 by L2. Is this clear? So, which carries 8 marks. You are going to get 8 marks. Very, very, very simple. Now, let us go to the next question of the potentiometer. Here the same question, but you are asked to determine the internal resistance. As I told you, internal resistance is indicated by small r. So, resistance posed by the interior or inner structure of a cell. The electric resistance produced by the elements existing inside the electric cell is called internal resistance, right? Now, draw the diagram the way we drew just now. Right. So, wire AB of manganese are constant. Draw a small diagram. So, primary circuit is very simple, connected to a standard cell of known EMF. Then this is connected to a rheostat RH, and this is connected to the end B. Primary circuit is simple and common. And secondary circuit, here secondary circuit consists two things. One is unknown battery of EMF, let us say some E, and to this you have a known resistor connected parallel, and these two are connected to a two-way key. Just to do the diagram in the previous case, draw a galvanometer and a jockey J. Is this clear? Now, in this case, you have to write the same description related to the construction of the potentiometer, then the working principle. So, first two paragraphs are same for the two questions. Now, let us straight away go to the working of this while measuring the internal resistance. So, internal resistance of this cell. So, you are supposed to connect one cell whose internal resistance is to be determined, as well as one known resistor. That means R value is known to me. It is a known resistor having resistance R. So, if you want, you can write like this, some P, Q and T. Now, connect P and T. Connect P and T. Then write move jockey J from A to B till you get null deflection. So, null deflection means Ig is equal to 0. In this case, potentiometer is said to be balanced. I am getting null deflection at a length or at a distance of L1. So, this is L1. In my first case, I am getting L1. So, L1 means, so E is directly proportional to L1. This is the equation number 1. Now, in the second case, you have to connect P and T as well as Q and T. So, in the second case, I am connecting this and this. So, current gets divided into two branches. Current goes through E, current goes through R. Is this clear? So, current gets divided into two branches and then recombines and goes through the galvanometer. So, combination of these two, there will be some potential V. So V is called the terminal voltage. Terminal voltage is the voltage between these 2 points because of the combination of both cell and external resistance. External known resistance, right? Let us go to the next page. So what I draw once again. So second case I am drawing. So both are connected to the galvanometer, to the jockey. Now I move the jockey from A to B. At one point I will get a null deflection that, let us say, that balancing length is L2. Now both are in the circuit. In the previous case only the C was in the circuit, R was in the open circuit. R is the known resistance connected parallel to the given primary cell. The combined voltage is V, right? So from our principle I can write V is proportional to L2. This is the equation number 2. The first equation was E is proportional to L1. This is the first equation and this is the second equation. Is this clear? Right. Now I can write E by V is equal to L1 by L2. Now what is the value of E by V? Now once again I will draw another diagram. This is the cell E which has got some internal resistance R. It can be taken as in series. There is an external resistance capital R. So current goes in this direction. So you can apply Kirchhoff's voltage law for this. So I am choosing anti-clockwise direction for my I am choosing anti-clockwise direction for my convenience. So I am going from minus to plus. So this is plus E. So here the direction of current is this one and the direction in which I am traversing is also in the same direction. In that case I have to take negative. And these two resistors are in series. So the voltage drop is, so I have to take negative. Voltage drop V is equal to I times R. I times R. But how many R's are there? 2 R's are there. This is equal to 0. This is from Kirchhoff voltage law. No need to write this in the exam. Directly you can write the value of E by V. Right. So this is E is equal to I R plus R. So E is equal to I R plus small I into small r. This IR is called V. So I can write this as, I will write here. So I can write that as E is equal to IR plus small I R. This is V. So I can write E is equal to V plus IR. I want E by V. So divide it with V on both sides. You will get 1 plus I by V times R. You know V is equal to IR. So I by V is equal to 1 by R. Substitute this here. So E by V is equal to 1 plus R by R. So straight away write the value here. E by V you can remember as 1 plus R by R is equal to L1 by L2. So next step is R. Next step is R by R is equal to L1 by L2 minus 1. Take the 1 on the other side. So this is R by R is equal to L1 minus L2 by L2. Is this clear? So in this question you are supposed to determine internal resistance. R, small r is unknown, capital R is known. So I want to write the expression for small r. Small r is equal to R times L1 minus L2 by L2. From this it is clear, capital R value is known. Both L1 and L2 are measurable values, are known values. So on the right hand side, everything is known. You will end up with some number. So in this way, you can determine the internal resistance of the cell by using a potentiometer. So these are the two important questions, and both the answers have some, what do you call, same part of answer. That means construction part and principal part is same. Only taking the ratio of E1 and E2 is different, and finding the internal resistance is different. Other than that, everything is same. I hope you understood these two essay type and important questions of current electricity. We will be meeting in the next video with another one or two questions. Thank you.